Hey guys, so this is a quick review of the Newton's second law experiment that we perform at the mechanics lab at Qatar University. So here we have a setup of two masses connected with each other through a string. Okay. Now what we'll do in this experiment is we're going to calculate the acceleration of the system. Okay. A theoretical value, and an experimental value. Okay, so with the experiment we'll get an experimental value and we'll compare that value to the theoretical value that we have. So we have an air blower over here. So when we turn this on, it blows air in the track, and that reduces the friction considerably, and then we can therefore ignore friction. Okay, so here's the timer. This measures the time. You have to keep this guy in this mode, S mode. Okay, so you can change the mode like this, but you have to make sure that this is in the S mode, and you have to press reset every time you take a reading. Okay, so let's and this button releases the magnet. So there are three positions of this magnet. Okay, so 1, 2, and 3. Okay, we're gonna, and you can release the magnet by pressing hard on this button. Okay, so we're gonna keep it in the second position like this. Okay, now let's take a reading. So what you'll do is let's first look at the data. We'll go through the theory afterwards. You have to fill up this table. You're gonna take different distances between the sensor and the mass, and you're going to find the time for each of that distance. You're going to take 3 readings for each distance, and then you're going to take the ratio of delta x divided by t average. So this is t average, and these are the units centimeters per second. Okay, so and then you're going to make a plot of delta x over t versus t. Okay, this is again t average, and then you will find the experimental value of acceleration using the slope. And let's take one data. Let's take one data point. Okay. So now you have to make sure that you measure the distance from the tip of the plate, which is around 19 centimeters. And you have to start off with a distance of 20 centimeters. Okay, so if this is 19, then this should be 39. Okay, so this is around 39. Okay, the center, you can measure distance from the center. As soon as this plate passes through the center, the timer stops. So let's turn on the fan. It's going to get louder. So let's press reset, turn on the fan. Okay, now I will release the mass. You will see that the timer starts. Okay. There you go. So it gave me a time of 0.849 seconds. Okay, this is the reading that you want. So it took the mass 0.849 seconds to cover 20 centimeters of distance. Okay, so that's your delta x. That's going to be your delta x over here. 20 centimeters, and T1 will be 0.849 seconds. Okay, and then you will take 3 readings for this distance, and then for 30 centimeters for 40, and 50 and 60. Okay, so you just have to move this guy 10 centimeters to take a reading for 30, and then so on. Okay, so that's it for the experiment. And let's go through the theory quickly. So we're studying Newton's second law. Okay, this is our system. We have a system of 2 masses that are on a frictionless surface. So these are the forces acting: tension, normal force, weight on mass m1, and tension and weight W2 on m2. Okay. So both of these masses have the same acceleration. If you write Newton's second law for mass m1, you get t. It's moving in this direction. There's no force in the vertical direction. So you get T equals m1a in the horizontal, and n equals W in the vertical direction. So these are your 2 equations for m1. For m2 is only moving in the vertical direction. So you get, since moving down, W2 is the greater force. So you get the equation to be W2 minus T equals m2a. So when you can take t from this equation and plug it into this equation. So you get W2 minus M1A equals M2A. So that gives you can solve for acceleration now. That gives you A equals M2G divided by M1 plus M2. So your M2 in this system is 11 grams, M1 is 212 grams. So if you plug in these values, you get the theoretical value of acceleration. Okay, so that's your theory. You have to make sure that your experimental value is close to this value. Okay. In addition, the manual I don't think asks you to do this, but you can also calculate the tension in the system. So, well, this is just a quick side. If you have friction, then the equation for mass m1, the horizontal equation modifies, and then you get a modified acceleration. But this was something in addition to the experiment. This was just a theoretical side discussion. So now you have a system that is accelerating with this acceleration. It's constant acceleration, okay? So this is motion with constant acceleration, and when we release the mass, we release it with zero velocity. So the position of the mass as a function of time is given by this equation, okay? So you get delta x equals half a t squared, and then you can divide t on both sides to get this equation. Now what we're going to do, if you plot delta x over t versus t, you get this as your slope. So the slope that you get from Excel, experimental value of your acceleration is going to be twice the slope from Excel. Okay, so you have to make sure that this experimental value is close to this theoretical value. Okay, so that was it for the review on Newton's second law. Okay, if you have any questions, post them in the comments. Thank you for watching. Bye.